Hello everyone, this is Mrs. Toops and this video is how to make a data table. If you would take out your pink packet and flip open to page 9, which will have the general instruction and an overview on how to create this very important table. When you design a data table, you have to take into consideration your experiment and the type of data you're going to be collecting. You've already created the experimental design, you know what you're going to be measuring, and the data table is the tool that's used to collect that information as you conduct the experiment. You'll use data tables really two different ways in our class. You'll construct a data table on paper that you'll use to collect data while the experiment is going on, and then you'll recreate that data table, or sometimes you will use class compiled data in your reports, and you'll have to reproduce that and make it a little bit prettier than what you use in the lab. So the important thing to remember, I want to point out a couple of things, and then there's a couple of horrible mistakes on the data table example that we need to correct on page 9. So let's get started. First of all, when you make a data table, you want to carry over the title that you have developed in your experimental design to the top of the data table. Now, we don't need the hypothesis, it's just simply the title of the experiment. Your data table is going to contain your independent variable and your dependent variables, and then sometimes it will also contain a column where you have had to calculate a value that you're going to use, and we call that a derived quantity. In other words, this was not something you collected as you were doing the experiment, but this is something that you calculated after all your data were in. So a couple of rules: always use a ruler, always use a pencil, put the title on top, and then when you think about your independent variable, that's going to really be in the first column. Here's the horrible mistake. In the first column where it says amount of water in the example here, notice that they put the units in every single cell. 10 milliliter, 20 milliliter, 30 milliliter. That is messy and ugly and just not scientifically savvy at all. So what you want to do is not do that. So scratch through those mLs, and you want to put that unit in the heading. So right here where it says amount of water, you should put parentheses and ml close parenthesis instead of having all that mess in there. Same here. We'll get over there in just a minute, but I want you to take a line right now and just cross that out and add the units up here. It makes a much more professional appearing graph. This is not a graph, data table. Okay, so our independent variable goes first. Then we move over to our dependent variable. Now, when you have repeated trials, you're going to have to account for those. The first line of this area is going to be the dependent variable, the title. This is plant growth and in millimeters. I don't even like the way they put in here because I just don't think that's very professional. I would put a parenthesis, close parenthesis there. And then you would have your trials listed below that because you have to account for that. So here's plant 1, plant 2, plant 3, and plant 4. Now again, this is poor design. Scratch through all of these MMs. This is bad for two reasons. Number one, it's redundant because you already have the units up here. And number two, if you were entering this in a spreadsheet like Excel, then this would be treated as a text field instead of a number field, and you couldn't do any calculations with it. So that's a pain. So make sure you go through and scratch all that mess out. Okay, the final column in this is the derived quantity. This is where the researcher is going to average the amount of growth for each of the repeated trials in each of the plants. At 10 milliliters, the average growth was 2 millimeters. At 20 milliliters, the average growth was 3 millimeters, and so forth and so on. Again, you repeat the units here in the title. You do not put them in each individual cell. That is redundant and bad form. And then if you have a spreadsheet, you can of course use the formula function and have it calculate that average for you, or you can simply calculate it in your head or on a calculator and enter that number. A lot of times what is going to be reported in a lab report is, or graphed, is going to be this independent variable and the average if you're doing derived calculations. So instead of making a really kind of cumbersome graph with all of these numbers in it, you're just going to simply calculate the average and graph that. Okay, so that's how to make a data table. We're going to use it a couple times. You'll develop a data table when you're coming into lab to capture the data as you conduct your experiment, and then you'll develop one that will be part of your report, and we'll also be collecting class data, so you'll learn how to do this on a spreadsheet as well. That's it for making a data table, and I hope that's helpful.